Yevgeny. I'm founder of Fuzzit. Came here from Tel Aviv. And in this session, I'll discuss fuzzing in general, and with focus on the GoFuzz library, as well as how to integrate fuzzing into your CI/CD. So before we start, how many of you know what fuzzing is? All right, quite some people. How many of you used GoFuzz in the past? Okay, not a lot. And how many of you really wrote fuzzers in addition to unit tests to your code? One person. Okay, so nice, nice job. So hopefully after this talk, you will all go and fuzz your code. So a little bit about me. So before Fuzzit, I did a lot of consulting with focus on security research, as well as fuzzing and penetration testing. I helped find bugs in other people's code, and hopefully this session will help you find bugs in your own code. And before that, I did a couple of ventures, some VC funded, some not. And before that, I served the cybersecurity part at IDF. Okay, so we'll talk about what is fuzzing, what types of fuzzers exist. We'll talk about GoFuzz library, usages, internals, how it works under the hood, and then we'll talk about how to integrate it into your CI/CD, how to run it just like you run unit tests. We'll talk about case studies, some trophies of GoFuzz. We'll talk about what fuzzing is not and what it does not replace, the future of GoFuzz and fuzzing, and we'll do some short Q&A. So what is fuzzing? So in its simplest form, like most of you probably know, just providing semi-random input in an automated way to a program to find bugs and crashes. So the second question that I get a lot is it only to find security or memory corruption vulnerabilities in unsafe languages like C, C++? Because as you know, Go is a safe language and it doesn't have those kind of problems. So the answer is that you won't find any memory corruption vulnerabilities in Go unless there is a problem in the Go runtime, which is unlikely. But you will find a lot of bugs in your code, as well as you will improve stability, code coverage. You might find logic bugs as well that might also have security impact. And essentially, you will be able to run millions of unit tests without writing them, and who doesn't want that, right? Okay. Okay, so there are a couple of types of fuzzers, and but I'll mainly talk about two types of fuzzers, which is essentially traditional and random fuzzer. The second one is coverage-guided fuzzer. So the traditional and random are essentially just providing completely random data to a test program, which is probably not very effective, and it's like the 0.1 version of the fuzzers, and the coverage guided, which turned out to be very successful, and I'll talk about how it really works, but essentially this is using coverage feedback to generate the data. So the first fuzzers that proved to be very successful were AFL and Leaf Fuzzer. AFL was developed by a person from Google. Forgot his name, sorry about that. So it turned out to be very successful. It's used by mainly to find memory corruption vulnerabilities in bugs in C, C++ and other native applications. And because it was so successful, a lot of the logics and how it works and the heuristics were ported to different languages. So in this session, I'll talk about GoFuzz, which is essentially port of, it's heavily based on how AFL works. So let's look at a simple example. It's called parse complex function. Essentially, this very simple function, just for the sake of the example. So what the function wanted to do is to test this byte array, and if it returns fuzzed, then it returns. If it gets fuzzed, then it returns true, and if it gets something else, it returns false. Someone can spot the bug here. Yeah.
Yeah.
Okay. What's the bug?
The length of the string is 6. You're for 5.
Yeah. Okay, so this one is actually an easy bug to spot, but for the sake of the example, so yeah, it will throw the Go runtime will throw an out-of-bound array, out-of-bound access, because if it will get the word fuzzy, it will access the sixth element. It's classic off by one byte. Before I show you how to use GoFuzz to find this bug, let's look at how the algorithm behind GoFuzz works and how the algorithm behind traditional fuzzer works. So traditional fuzzer is essentially just generating random input, executing the input in infinite loop. And in coverage-guided algorithm, we have one preliminary step, which is instrumenting the program for code coverage. So this is when it builds the program, compiles the program. You instrument, you add another step, and you instrument the code for coverage. Then we have something called the corpus, which is essentially just a directory with test cases. So you choose a random input from that corpus, from that directory. You are doing a mutation on the input that you randomly choose from that corpus, and then you execute the input. You collect coverage. If you get new coverage, if you hit new paths, then you add it to the corpus. So essentially, this is a very simple form of, it's called genetic algorithm, where the strongest survives. So you add to the corpus only test cases that get you to new passes, to new code coverage. That's it. I'll talk about a little bit about the mutation, but I think like the most important thing and understanding was really that collecting the coverage and mutating only on test cases that get you to new coverage got coverage-guided fuzzers to very good results. For some confusing reason, the random fuzzer is called GoFuzz without a dash, and the coverage-guided fuzzer is called GoFuzz with a dash. So the one that you want to use is GoFuzz with a dash. It was initially developed by Dmitry Vyukov from Google. Now it's also maintained and contributed from other developers around the world, but he did most of the work pulling this off. So on the left side, we see just the random fuzzer. Essentially, we call the fuzzing framework, and it generates us random string data, and then we call our function parse complex in a loop. I ran it for 1 hour, but essentially it will never find the crash, because the crash will happen only when it gets the word the string fuzzy, which essentially the probability of the fuzzing framework to generate fuzzy from all the strings in the world is 0. So it will never find this crash. On the right side, GoFuzz, you have to implement a function called fuzz. It gets a byte array, and the GoFuzz framework will call this function infinitely, and will pass the data depending on the algorithm that I showed in the previous slide. So then you pass this data to the parse complex, and it will find the bug in about 1 second. To run it, you have to install using go-get the GoFuzz and GoFuzz build. Then you call GoFuzz build, which essentially builds the binary with the coverage and instrumentation. And then you just run GoFuzz, which this essentially runs the instrumented binary and providing the random data with the coverage instrumentation. So this finds the question in 1 second. And if we look at the data generation of the fuzzers, so the first fuzzer, the traditional one, is just generating random input, so it will never hit our crash. And on the right side, this is not all the data that were generated. This is just the data that were saved in the corpus, just the strings that hit new coverage. So you can see that every new character essentially hit new coverage in our if statement, and essentially in the end it finds fuzzy and it gets to the crash. Another example of what we can do with fuzzing is, so I'll ask another question before that. How many of you heard about property-based testing? Oh, okay, cool. So property-based testing essentially is, it's a bit confusing term, at least in my opinion. So it's not connected to properties and classes. It's connected to something, to a property that is always true in your code. So for example, if you have an encoder, then if you encode the data and then you decode the data again, it should always equal to the same data. So there are a lot of property-based frameworks where they generate random data using, usually using frameworks like completely random, like we saw in the previous slide, just random fuzzers. So essentially you can do similar things with GoFuzz. You can do property-based fuzz testing, which should get you to better results. So you can do, for example, call minecode data, and if it doesn't equal to data, you found the logic bugs. You find a logic bug and you can assert that. So it's not only crashes, you can also find some misbehaviors. Okay, so this is trophies. This is, you can find also on the GitHub GoFuzz. This is just 1/10 of the documented bugs, and I think there are much more also undocumented bugs. A lot of them are in the standard library, some of them are not in the standard library, and other big projects. Essentially, from my experience, every project that is in some sort fuzzable and it didn't run a fuzzer, it will find a bug in probably in the first few minutes. Yeah. Sorry? Yeah, this is trophies for GoFuzz. Find bugs probably in the first few minutes, and then probably it will also find in the next hours find bugs. So mutations. A little bit about mutations. I won't deep dive into this, but there are some mutations like bit flipping, adding bytes, byte flipping, doing some arithmetics like incrementing integers, and probably some more. You can read, like if you want to deep dive into the into how the mutations work, you can look at the AFL white paper. I think some of them are described there. And there is something called sonar in GoFuzz, which is a way to bypass, for example, checksums. So if you have some kind of a checksum in your code, then it will be hard to guess, for a fuzzer to guess the right parameter to get away, to get past that checksum and to get the new code coverage. So essentially, GoFuzz is also looking at the code itself and sometimes even executing some of the statements to get to the right data that it needs to pass to the program to get to new code passes. So this is short. And okay, solutions and what fuzzing is not. So it does not replace unit test and integration test, but on the other hand, if you have a unit test that looks like, let's say, if you take a Go table-driven test and you have a table with just 10,000s of strings or test cases that you generate, you probably can put less tests there and just test things that you know that you want to test them, and then go to GoFuzz and let GoFuzz do the job for you, generating good random, it's not really, but good test cases, and getting to new coverage and finding bugs. So secure design and red modeling. So it does not replace that. You can, if you run the fuzzer, it doesn't mean that you don't have bugs anymore in your code. Probably you will still have bugs. So you need to think about what will be the problems, and even if there are bugs there. So it does not replace secure design and up-to-date third-party libraries and other secure software development best practices. So who is writing the GoFuzz functions or GoFuzz targets? So as a developer, just like you run just like you write the unit tests, you will want to write the fuzz functions. It will probably be easier than writing the unit test because you will have just to write one fuzz function and it will execute thousands of unit tests. So you're the best person to know what parts of the code are fuzzable, what you should fuzz, which function you should call. So probably you should do that. Okay. So continuous fuzzing. So running a fuzzer once is nice and will probably find bugs. But just like unit tests, you want to run the fuzzers every time you push new code. But unlike unit tests, which are quick, hopefully, fuzzing can run indefinitely. So there are some new questions that arise: is how long should we fuzz? What versions should we fuzz? And where should we run the fuzzers? Essentially, a word about Fuzzit. So essentially, this is what we do. This is what we help projects and companies do. We help them integrate fuzzing into CI/CD workflow. We are free for open source projects. So if you have an open source project, you can use us for free. But essentially, you can also roll your own thing, and the logic behind that would be the same. Okay.
So with random fuzzing, you have random inputs.
Yeah, but one second.
With no fuzz, you have a corpus.
Yeah.
How do you initialize that corpus if you don't have a corpus yet?
Yeah, good question.
How do you start with the GoFuzz if you don't have inputs that are expanding coverage to start?
So, good question. I'll take that question, and then let's skip the questions to the Q&A. Okay. So the question was, if we don't have a corpus, how it generates the data initially. So if we don't, it can start with an empty corpus. It's totally fine. It will just start probably with some empty string or something like that, and it will still get to very good results. Just will take more time. So if you have good test cases, that valid test cases, that will help speed GoFuzz to get him to better results. Yeah. Okay. So continuous fuzzing workflow. So we help integrate continuous fuzzing to a lot of open source projects. Some of you probably you know, like Envoy Proxy or Prometheus. And from our experience, there were mainly two workflows that were successful in our opinions. So one is the fuzzing workflow, and one is the regression workflow. So the fuzzing workflow looks as follows. Essentially, anytime you push new code to master or to your development branch, you build the fuzzers in the CI just like you build your code, your Go code, and then you upload them to a server where you run the fuzzers, because the CI usually has a timeout and it doesn't fit well to long-running tasks. So you upload them to a server or to Fuzzit. You run the jobs, and essentially the fuzzers will run either until it finds a crash and then you get some kind of notification, or until a new version of the fuzzer is uploaded. So every time you push new code, you push the fuzzer to the server and you stop the old fuzzer, the old version, and you start the new one. And the important thing is that you save the corpus. So the fuzzer won't start from empty corpus or from the beginning again. So essentially, like for example, running a fuzzer for a year for most projects probably will be an overkill, but you don't really run the fuzzer for a year. Essentially, depending on your workflow, you run the fuzzer actually for a day or a few hours, because every day you push new code to master, and essentially this fuzzer will fuzz, hopefully it will fuzz the new code that is added, because it is starting from the corpus, from the corpus from the previous run. Okay, so this is the fuzzing workflow and the regression workflow. So now we generated a lot of very good test cases that get you to a lot of coverage, and we want to take advantage of those test cases. So what we do is, for example, for every pull request, we download the corpus directly into the CI. You can do that directly in your continuous integration, whatever, Jenkins, Circle, Travis. You download the corpus, and then you run the fuzzers through all the files available in that corpus, and this is usually very quick. It takes usually few seconds, just like tests, and then you can see if fixed crashes or test cases didn't crash your program. So essentially, old bugs didn't propagate again if you didn't introduce new bugs. So this is essentially free unit test for your pull requests. So this is some continuous trophies. So even people that had already GoFuzz functions written, no one's running manually the test that they write every push unless it's in the CI. So of course we found new bugs. Okay, a few words about the future. So fuzzing started with mostly started with fuzzing programs that gets data from the network. So all the fuzzers started by generating a byte array or essentially a string of bytes. But most programs or a lot of programs doesn't work with stream of bytes as input, so they get structured. So you want to test programs that get structured, like sometimes databases, HTTP handlers, and there is an open issue in GoFuzz, and some people are working on it, and hopefully this will be merged and will be in the next version of GoFuzz specifically, and also in other frameworks and other languages as well. And also there is also an open issue about providing fuzzing or essentially GoFuzz as part of the Go standard library, just like GoTest, which is essentially part of the standard library. Okay, Yevgeny.
In one of your examples, you had GoFuzz and a build tag. Can you explain how that works?
Yeah. This one, yeah. So the question is what is the build tag GoFuzz? So when you write GoFuzz build, essentially, what it does is that when you just doing Go build, you don't want to include this fuzz functions in your production build. So this helps you eliminate that. Okay. Any more questions?
To be clear, when let's say you're using this fuzzer, right, and you rewrite your function, and now your function has a completely different set of expectations. You just go to the corpus and delete the corpus and rerun it.
So you don't need to delete the corpus. It will. You can start with test cases that are essentially every test case is a good one. There is something that's called corpus merging. So it will essentially GoFuzz will delete the unnecessary test cases by itself. So it will only keep test cases that gets you in the end gets you to new coverage. So if there you change your code and now there are, let's say, 10 test cases that gets you to the same code coverage, it will be deleted or merged into one test case.
You have another question?
Yeah.
Can these fuzzing libraries generate more than just strings?
Yeah. So this is exactly what I said. That currently it works best for it's not string, it's byte array. So it works best for byte array, but you can. I saw a lot of use cases that you can just transform in your fuzz function the byte array to some more structured data. But there's work that being done to generating structures as part of the GoFuzz library and not as part of the user that writes the function. But you can essentially do that transformation yourself for some simple cases.
I have a question. So about corpus. So is there any cost to maintain corpus? I'm more concerned about the operation. Like for example, how big corpus would be usually the average, and how do you maintain corpus? Do we need to sometimes regularly doing hygiene on the corpus to make sure they're effective or what?
So I'll repeat the question if I understood correctly. So the question is, do we need to? The question is, how big is the corpus, and do we need to merge it or something like that?
How do you, for example, do you need to maintain the hygiene, like maybe corpus after a while become outdated or whatever? Do you do something like use corpus to find out possible common errors like code to fix those things first?
So essentially, GoFuzz and another. Okay, there is another. Essentially, GoFuzz and other libraries as well. Like, for example, Fuzzer. They have what we call merging. So they check that you don't have test cases that don't get you to new coverage, and they delete them. So you can run merging periodically. I think in plain GoFuzz this is done automatically, but I'm not sure. In libfuzzer you have to run it periodically. But usually the corpus is not growing exponentially because you don't have essentially exponential code coverage.
More questions? We'll take one more, if anyone has any. If not, we can all put our hands together and figure out the problem.
Thank you.